right, we've talked about perimeter. Somebody tell me, what is perimeter? Not how do you find it, what is it? McLean.
The measurement of the lines outside, how big it is on the outside.
How big it is on the outside. Clean her up a little bit, Wicker.
The distance around the shape.
All right, the distance around that shape, which you're right, McLean, you had the right thought. We're going to measure the sides of a straight-sided figure, and then what's the mathematical process to find perimeter? Just what is the math? Add. There we go, Cody. Good job. We add to find perimeter. Bless you, ma'am.
Thank you.
Now, yesterday we did area. Rectangles and parallelograms. What is area? Remember, I didn't ask how do you find it. I said, what is it? What is area?
The space.
I don't think we wrote down space. Brad?
How many squares are in a figure?
No, I didn't use in it. I said covers it. So you're right, Brad. Area. When we measure area, we are covering the figure with squares. The measurement is squares. We're putting squares on it. We're not going around it like perimeter. We're covering it with squares. Now we're going to continue today doing area, but we're changing figures. We're doing triangles. Now I want to develop. What is a triangle? Well, what is it?
Three-sided figure.
Looks like these things right here, right? Three-sided figure. Okay? You got it there, Carl? See that? All right. Here's our triangle. It's got a bunch of squares in it. If I want to know the area, I can count all these squares, right? Oh, but we got a problem. Because there's a square that's not a complete square. There's a little not a complete, not a complete. That's not a complete, not a... You get the idea. But what mathematicians do? They discovered, they didn't come up with it, they discovered, God already invented it. But they discovered a formula, a mathematical process that could help us find how many squares without having to count them. Right? So I want us to develop where did it come from. And last period when I did it, it blew a couple of brains up. So if it blows your brain up, don't worry about it. Just trust whatever we get is the true thing, okay? So I want us to entertain a thought here. What's this bad boy right here?
Square.
Parallelogram.
Carl, you can't say anything because you got the filming, okay? Sorry, man. Parallelogram. What's it about? Parallelogram, right? Y'all agree with me?
Yes.
All right. Let's look at something here. What's this right here? Parallelogram. That parallelogram, isn't it? And if I cut from this corner to this corner, what does it make? A triangle. What else do you notice, though? A parallelogram is two triangles. Well, let me try something else. This is a rectangle. I cut from here to here diagonally. What do I have? Two triangles. And a rectangle is a parallelogram, right? All right, Brother Cody, do you discover something?
The formulas are probably going to be similar.
They're going to be similar because looks like the triangle came from a rectangle or a parallelogram. But what are you noticing, y'all? McLean?
The shapes are congruent.
Oh, what does the word congruent mean?
The same.
The same. So, are we saying if I cut from corner to corner, a diagonal, on a rectangle or a parallelogram, it makes what? Two equal shapes. So, are we saying that a triangle is what? Half of a parallelogram. What was the formula for the parallelogram?
Base times height.
Base times height. What do you think this is going to be? Base times height.
Divided by half.
Divided by 2.
Divide by 2 or half it. You agree? If a triangle is half of a parallelogram, then its formula must be half of whatever this guy's formula is. Correct? We agree?
Yes, sir. Yes, sir.
Because we're not dealing with the whole thing today. We're dealing with half of it. You with me, Amy? This came from here, and it's only half of it. Yesterday we base times height. Today we're going to half of the base times height. So, I'm guessing our area then is half of the base times the height. What y'all think?
Yes.
Weren't we yesterday base times height?
Yes.
Today we're only doing half of it because a triangle is half of the parallelogram. Right? Look on your tax chart. Look on your tax chart. What does it say for area of a triangle? A equals half base slammed against height. What does slammed together mean? Times. Slammed together means time. That's what we got, wasn't it? Now, it has an or on there.
Or A equals.
Hang on, wait, my mark not ready. Or A equals.
BH.
Wait, y'all say BH. What is that?
Base times height.
Base times height.
Over 2.
What's over 2 mean?
Divided by 2.
Ah, fractions are like dividing problems, remember? I personally like this one, the bottom one here, or the second one on the tax chart, because I personally don't like fractions. I've told you that ever since we started with fractions. If there's an easier way to do it, then I can leave fractions off, I leave the fractions off. I'd rather divide by 2 than half something. Because when I half something, it is dividing by 2. Isn't it? All right? So, I think I like that. The problem is, B and H represent numbers. And I need to know where do they come from. Well, last time I checked in a triangle, or in something, yesterday I parallelogram, where was the base?
The bottom.
The bottom. So I'm going to put B on the bottom there. So I want you to draw 3 triangles by our formula here so we know where the B's coming from and where the H is coming from. Alrighty? Draw it by your formula. Base is the bottom. Now yesterday on the parallelogram, you got it drawn? No. Ah, that's what I was thinking. You need these, buddy. Right by the formulas. Yesterday, what was the height?
Where the corner and the you can draw a line and touch both straight line.
Straight up and down. Sometimes a dotted line, but it was a straight up and down line, wasn't it? Because when we measure your height, we don't lean you over and measure you, do we? We say, no, stand up tall and straight. So we're looking for the straight up and down line. So even on a triangle, we need a straight up and down line. But since it's not a parallelogram, it goes from one corner down to the base and forms a right angle. That's going to be our height. If I draw a straight up and down line from way over here, right here, is that how tall that triangle is? No, I got to take it all the way to the corner up there. Okay? All right. Get it? Bingo! First person this year, and I love it. Mackenzie says, hey, do y'all notice with the right angle box, what does it make?
An H.
An H. Ding, 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 ding. Good job, girlfriend. Very good. Now, look at this triangle, y'all. Base. Yeah, I say base is right here. Uh-oh, what's the height?
The straight up line.
You see the H? It happens in a right triangle. In a right triangle, one of the sides is actually the height because it's the straight up and downy one. Right, brother? You with me? Time to go and sleep. Now, also on a triangle, my student last period, when he erased it, drew back this ugly looking triangle, but that's all right. Sometimes, friends, like the parallelogram, what do they sometimes do?
They try to trick.
They put the height on the outside. Okay? They put the height as the straight up and down dotted line outside of it. It's still the height, okay? Okay? Okay. Am I all right with that? So do we know where the H and the B come from? We're going to look for it. These places on the triangle.
The little H that they make on the
There you go. All right, so let's do some examples. Let's do some examples. Let's find the area of this bad boy right here. A equals
15 times 20.
All right, base
B
20 times 15. Now that's kind of being a snoot head about it. I'm being a snoot head. Remember, B's first, so let's try to use B first so we don't get things switched around, okay? Base times height. 20 times 15.
300.
No, we're not done. This is where last period went nuts on me.
Divide by 2.
Divide by 2. Don't do any mathematics until you have the whole thing written down. Now, if you like fractions, you would write down 1/2 20 times 15, okay? If you like fractions. Notice I used the second one, didn't I? All right, 20 times 15. Now let's work it.
300.
300 and divide by 2. 150 square inches. We talked about how to say it yesterday. You really need to say the square first to be mathematically correct. Now, you want to know a shortcut? Remember I told you if there's a shortcut, I'll tell you, right? There's a shortcut. Makes the math easier. Okay? What's this, Luke? We're sitting here with 20 times 15 over 2. It doesn't change. I still got to fill in the formula. Watch this. What's 20 divided by 2?
10.
You still have times 15. What do you get?
150. So you divide.
Do your division first. Makes it a lot smaller numbers to do multiply.
Wait.
Okay, watch me this time. Here we go. Don't take your eyes off. What's 20 divided by 2? 10. So that takes care of that. Still got times 15 now. 10 times 15.
Oh.
150. Yep, back. Okay? Everybody all right with that?
1450.
Okay?
1450.
Kill it.